Paul, we're here at FANUC UK today looking at this robot here. Now, most people would associate FANUC robots with being yellow in colour, but this one's green. What's the difference?
The difference is with this robot, it's a collaborative robot compared to a standard industrial robot. But we say, generally, if you cut it in half, it's still yellow. It's still the same reliability that you get from FANUC, same design, same service.
So what does collaborative mean then? What's the difference?
Collaborative means that you can actually work with humans next to the robot without actually having any guarding in a safe environment.
And how does that fare on health and safety then? Will this robot stop when you go near it? Is that the idea?
Yes, it will do. It's to the latest, to the highest safety standards, Category 3 PLD, to all the latest safety norms. And if you go and touch the robot, then it will stop working.
Can you stop it and start it then? Show us how that happens.
Yeah. Let's just pretend there's somebody in the way. There's a collision. It's as simple as that.
And then to get it going again?
It will start again automatically after a certain program time, or you could go to press a button to say the obstacle is now clear and continue running. Here we're just demonstrating an example of machine loading. So it's picking a part from a pallet and going into a nick and index head where it would be possibly machined or turned or whatever, and then unloading, and then it's just doing a little bit of a move around to show off.
And how would it go about programming something like this then, Paul? Is it dead simple?
It's standard FANUC robot language. Teach pendant language is one way of programming. So if you're familiar with teach pendant robot, FANUC robot language, it's exactly the same as a standard industrial robot.
And imagine if I wasn't. What is that? What is that teach language? What are you doing? You're moving it to position to show it where to pick parts up?
Yes, you just drive it to a position and record a position. You get an interface between the machine and the robot for what we call inputs and outputs, I/O. So it knows when to load the part and when to unload the part. But with the new FANUC robot control we have coming through, the 30IB Plus, we have a software in there called IHMI, which is an intuitive robot program language.
So would I say from this then that you've got eight parts in there? You'd move the robot to the first part, and then because of your grid positions, you'll know where the other 8 are. So you'll just tell it where to pick up part 2, part 3, part 4, and so forth.
Yes, it would just be an offset in 2 axes.
And then when you're putting it into the nick and unit here, is that exactly the same? You teach it where the unit is and where it's coming to, and then the nick and unit clamps and then it pulls away?
Yes, exactly. Yeah, that's exactly right. It's just one teach position to load the nick and unit.
So why would someone go for this solution as opposed to one of your normal robots, Paul?
Probably where you're looking at using, where your application is for lower batch sizes, much smaller batch sizes, and they're not high volume production, where you're not so concerned about your robot loading and unloading times, where you need to be more flexible and program a robot very quickly, and you just much smaller batch sizes.
It strikes me again, one of the thoughts is you could move it around the works, could you, to different machines, because you haven't got to worry about guarding and things like that, and moving all that as well.
Yes, you could do that as well. Because you haven't got the guarding, you're exactly right. It makes it a lot more flexible to be able to apply it to different applications.
And the robot we're looking at here, the CR7IA, it seems quite a small one. Do you expand in terms of size and weight that they can pick up?
Yes, we go up to 35 kilogram payload on the CR35, which is a standard, underneath the green covers is a standard M20 FANUC robot. And this particular one is for 7 kilo payload, and we go down to 4 kilos. So it's the full range and expanding as well.
And it wouldn't necessarily matter what you're integrating it to, because all of your controlling and your programming is coming from here, from your control side, isn't it? So it doesn't matter what brand of machine you've got, what you're trying to load. Everything is independent here on the collaborative robot in terms of programming and setting.
As far as yes, other than just setting up with some inputs and outputs to control the door or the time to unload and unload. Other than that, it's all in its own control.
And we can kind of see where they fit. Then my final question to you is: would they be more? Is the collaborative robot more expensive than a traditional robot, or or is it less, or is it the same?
It's a little bit more expensive because at the base of the robot there is a sensor, which is what gives it its collaborative mode, and senses when there's a collision or there's anybody in position to stop it.
So if you were coming new to this completely, how long do you think it would take you to get to grips with something like this? Excuse the pun there, picking the part up, but how long would it take you to learn?
With the IHMI software, we're around about 20 minutes to half an hour straight out of the box.